Hello and welcome to this episode of T-Tech. Today we're going to be installing the Nginx web server on Linux. So specifically, I'm on Debian Linux here, but this works, the important aspects of the config work on every distro out there. We're going to log in as root first. And let's start by doing an apt-get update. You want to make sure that the packages you have are up to date before we continue. All right, now let's go ahead first before we install this, and I want you to check the Etsy network interfaces file here. And what I've done here is I've set a static address. Do make sure you set a static address and a gateway before you follow along with the rest of this. Same thing in Etsy resolve, just in case you didn't know. Make sure to set the DNS servers there for yourself. And then we can get started with this. So let's do apt-get install Nginx. And this goes ahead and installs the web server for us. Let's go ahead and pause this. It can be a little bit lengthy. Alright, so now that it is installed, we're going to go to Etsy, Nginx, and then in there we're going to back up the original Nginx conf file. We want to back that up to an original version so we're able to roll back if we make a mistake. Now let's remove that first config file, and I'm going to use vi here and make a new one. Feel free to use nano if you want to or something different. So here the first thing is HTTP. We want an opening curly brace there and a closing one. You do want to make sure they're matching. And then we want to have a server clause here. And then again, opening and closing brackets. Now inside of the server clause, we want to tell Nginx what ports it should listen on. So to do this, we're going to say listen 80 to mean listen on port 80. And under that, we're going to say server underscore name localhost, and that with a semicolon as well. And if you have a domain name for your web server, put that in there instead of localhost. Now under this, we're going to make another directive for location. And this is the URL of the website. So whatever you type in your address bar, this is the information that it's going to show you. So for now, we're going to have location slash, and we're going to have those braces again. So inside of this, when you go to the website with slash, we want to tell it where those files are to serve you on this server's file system. So we're going to put ours in Etsy, Nginx, test, and that with a semicolon here. And then under this, we want to tell it what index files to serve. We're going to say index.html and index.htm, then have a semicolon there. So in this case, if you put slash in, this is going to get files from Etsy Nginx test, and then it's going to search for those files as an index. Okay? Otherwise, it'll just give you a 404 error. So outside of the HTTP brackets, we're going to say events. And then same thing with the brackets there. But here we're going to say worker underscore connections. We're going to say 1024, then a semicolon. And this means how many processes Nginx will use for web connections. So how many, connections are allowed. Now there's one I'm going to show you outside of events as well. We're going to say user www-data and then end that line. Now this is important because if you want to create other users and do this with it, it's important to understand what this means. The normal process for Nginx runs as root, and when a web browser connects to the site, it starts another child process. And the thing is, that child process has the privileges of whatever user we say here. All right. So the advantage is if the Nginx web server is exploited, any code that the attacker then runs only with that user's privileges, not as root. So that kind of minimizes the damage that could happen. With all that said, though, this is what we need for a basic plaintext web server with Nginx. And we do need to actually make a file for that location, though. So let's save that there. And now we're going to make that directory test. We're going to go in there. And let's vi index.html. Okay, we just want to make a very quick basic website. This is a website hosted on Linux by Nginx. And then we're going to end that paragraph tag. And then we're going to end the body and the HTML. All right, if we cat that file, there's our website there for us. So now that we have this, we're going to go in and do systemctl start Nginx. And if it starts up and doesn't tell you that it had an error with the config file, your syntax is correct. And you can also do stop, of course, or restart as well. But let's do status Nginx. And it's been running. So you can also, let's do a restart just to show you. Oops, one too many starts in there. And then if we do the status, and it's just restarted. So let's do netstat-anput. It is listening on port 80. Now, if you want the newer command, I've been around this stuff for a long time, so that's why I use netstat. But they're moving now to SS, and for that we're going to use show sockets is what it stands for. We're going to use SS-L for listen and T for TCP, and then N to not resolve the names of the ports. So, all right, it's listening on 80. So with all that, we're going to take a stop here, and then when we come back, we're going to visit that website at whatever static IP you put in there, and we'll see our plaintext website work. That address, so HTTP 192.168.0.1. We see this is a website hosted on Linux by Nginx. And again, if you change anything in that file or add more files, hyperlinks, what have you, it will show those on the screen, and you just refresh, and your browser will get the new resources from the web server. So that is how we set up a plain text web server with Nginx. But stick around, and we're going to expand on this a little bit more. All right, so we set up a plain text one, and that obviously, with that, any data going over the network can be seen by anybody on any router at any service provider or data center, or even public Wi-Fi. Obviously, we're going to now set up public and private key encryption. This is also known as asymmetric encryption. So we're going to go to etc Nginx, and we're going to make a directory Nginx_SSL and go into that directory. Now, you can put these in a different location. You could put them in etc SSL. We're keeping them all together to make it simple and easy to understand. But all of these things, even the website, have a default directory. You don't have to do what I've shown here. Exactly. So now we're going to make those keys. So we're going to use OpenSSL request, and the certificate type is X509, and then the hashing algorithm for them is SHA-256, and then we're going to say new key, and then it's going to be type RSA, and then the bit length is 2048. You can go higher than that, but this is basically how much data the key's length, how strong it is to brute force and break, basically. Now, we're going to say key out, and this is going to be called ttech.key. You can have this be your domain or whatever have you. So this key, though, it's the private key in this pair. And the private key is only for decryption of the information this server receives in the connection. All right? So the next part of this pair is a Crt file, and this is the public key. The public key is what's used to encrypt data that you're going to send to this specific server. So these keys, once we create them, they're only valid for so long. And in this case, I'm going to say 365 days for 1 year. And lastly, we want to specify we don't want DES, which is an older encryption standard that normally we don't want to use, we want to avoid. So with that said, we're going to hit enter on this command, and we're going to say US, and I'm going to say test here, of course, but if you're setting this up in production, do fill this with valid values. But we're just going to hit enter on like all of these here. Again, like common name, you'd put in your domain name, obviously. And we should be left with ttech.crt and ttech.key, or whatever your domain name is, and those. So we're going to cat ttech.crt. And this is, again, the public key. So what happens is whatever data that I have that I'm sending to the server, I take that data, known as the plain text, and I combine that data with this public key string. And then that creates the encrypted value. Now, the reason it has to be encrypted with this public key specifically is because when the server receives it, it uses this part, the private key. It takes the encrypted or data or ciphertext it receives and runs it through this string as well. It combines the two. And when you do that, you end up decrypting the data in the connection. So then it can interpret the data, and then after that, it can take the client's public key in his key pair and encrypt the data for it and then respond. So both of these, the server and client, provide keys. So with that, we're going to go back one directory, and let's go back in to the original config file. So in here, inside of the HTTP directive, we're going to make a new server directive with its own brackets. And in the brackets here, we're going to say again, let's bring that up for the other one. 1 second. There we go. We're going to say listen. But this time, we're going to say listen on port 443, the standard port for SSL. And we're going to say SSL and then a semicolon. And then again, the server name. And it means the same thing, and the same things apply as the plain text. But here, we're going to do the SSL specific configuration. So we're going to say SSL certificate. And this is going to be the location of that private key. This is etc Nginx, Nginx SSL, ttech.key, and then end that line like before. And then the SSL certificate key. And this is in that same location, but it's going to be ttech.crt. Now we also want to specify things about the ciphers, so the session rather. So we're going to say SSL session cache. This is how long it holds on to a client's encryption information, because each client has unique public and private keys they use for each session to the server. And we're going to just say shared :SSL. And then after that, we're going to say :1m, and then end that line. So we want to remember the sessions for around a minute. And we want to time out sessions in 5 minutes. All right. And now we're also going to say SSL Ciphers. And this, when client and server, it doesn't have to be a web server. This could be an SMTP server or an SSH server. They have a SSL hello message. So they have an exchange where they say, this is the hashing algorithm I support. What do you support? This is the encryption algorithm I want to use. Which ones do you support? And in addition to those things, this is when they exchange the public and private keys with each other. So then they can pass these messages, but being encrypted and protected from anybody in the middle seeing them. So what we're doing here is telling the server what it should communicate with, because there's many, many options that have been created over the years. So these are going to be high priority. So we're going to say that we don't, with an exclamation point, we don't want to allow null. So we don't want to allow either side, the server or the client, to say we don't want encryption at all, because that is an option. So then we'll have a colon to separate that. And then with the hashing algorithm to verify the data integrity, we don't want to use MD5 at all on either end. And then we just want to end that line. So now that we made it all through the SSL certificates and keys, the rest of what we're going to put is the same as the plaintext server. So we're going to put location, and we're going to have the brackets there, and then we're going to put in that root, and we're going to actually, in this case, specify the same directory as the plaintext, so etc Nginx test. And then we're going to say the same thing for the index files to serve, just like that there. Then you do want to make sure you have the right number of brackets there. And it looks like we do. So with that, we're going to save our file here. And then we're going to let's stop Nginx. And let's start Nginx. All right. I'm going to go ahead here and run this journal XE for you so you can see what's going on. All right. The whole issue is I can't read that file. So real quick, we're going to go back in, verify we typed everything right, and verify the permissions. I'm going to go ahead and fix that, and I'll be back with you in a second. All right, it wasn't even a permission problem. So just make sure under SSL certificate you put the public key there, the cert file, and then SSL certificate key, you put the private key, so the .key we created with that OpenSSL command. All right, so now with all that, let's restart Nginx, do an SSL LTN, and it's on 443 now, or if you want to use netstat, like so. All right, now let's hop back over to the web browser. We're going to go to that same address, but now because we've set up public and private key encryption, we will be seeing that data over a private connection that is unique between that specific client and that one server that no one in the middle can see at all. I'll see you there in a second. Alright, so now we are on our plain text website and it says not secure. Now we're going to type https://192.168.0.1. And now it says the connection is not private. Now the reason it's not private is because normally when you create a public-private key, you take that public key and you pay an organization called a certificate authority. Now what they do is they basically take a pen, so to speak, and put their signature on it, just like it's a piece of paper, to verify that the certificate can be trusted and the server you're connecting to is who you think it is. But in this case, we are our own certificate authority. It's called a self-signed certificate. This is fine for testing. Just don't do this in production. So we're going to hit advanced there and hit proceed. And now, even though it says not secure, if we click that, this does not mean the encryption and the hashing and everything that goes with SSL and or TLS is insecure. It means we don't know that this is the real site you think you're connecting to. So we're going to click certificate. And this is our certificate we just made. It's valid for 1 year. And you see it is not trusted. If we go to details, we can see it has that, default OpenSSL text in there. The SHA-256, you see how that relates. And it's an RSA 2048, that new key parameter we had. And certification path of it is just the internet widget, the default OpenSSL path. And you could have put test in there. Your domain is what you want to put, your company, obviously. But that is how we set up public and private encryption on Nginx. So with all that, I do hope you enjoyed this video. And as always, this has been Tyler with T-Tech. Thank you for viewing. I really do appreciate it. And have a very nice day.